You're looking at what?
Behind you. You'll find it.
Nice. Comes off really well. Alright. So, just like yesterday, today we're just going to look at some different graphs. We're going to try and pull information off it. For those of you that weren't here yesterday and didn't watch the video that I posted so nicely for you, if I had to guess, we'd have a section of our test that is probably drawing graphs and creating tables.
That's why.
That'd be like what we did day one.
It's really easy.
Really easy. And then we'd have another section of our test that might be like looking at graphs and plots and things like that and pulling information off of them.
But that's just a guess.
That is my guess. I mean, I'm a pretty good guesser, but it's never 100%.
You always guess wrong. You said that first.
I don't think I said that. I think I said I never guess wrong.
But it was in that class. I mean, he probably wasn't paying attention.
He's probably looking at his phone. Alright, so, just like we did yesterday, we're going to look at some graphs, we're going to take some information off of them. If we're looking at this graph, what kind of graph is this? It's a bar graph, right? Now there's two different parts to it. There's small cups and large cups, but there's a bar graph. There are spaces in between each different category. So, I'm looking at my bar graph here. We're talking about the juice sold at Sunny's Diner. What would the most popular juice be?
Orange.
Orange. Dom, why is it orange? How do you know that? It's the longest. It's the two biggest ones, right? So we know that that's got to be the most popular. It's the one that happens the most frequently. Well, if small cups hold 8 ounces, large cups hold 14 ounces, how much juice of each kind is sold? Oh,
Do some math.
how are you going to figure this out? Multiplication. How do we? What do you mean by multiply? Just 8 times 14?
No, like if you're doing grape, it would be 10 times 8 plus.
Perfect. So there's 10 small cups of grape sold, so we would do 10 times 8 plus there are 15 large cups sold, so 15 times 14. So we would take the number of little cups times 8 plus the number of big cups times 14. For grape, we should get 290 ounces. Apple, small cups, we had 20. Large cups, we had 30. 20 times 8 plus 30 times 14. She gives us about 580 ounces. Cranberry, 20 small cups, 15 large cups. 20 times 8 plus 15 times 14 gives us 370 ounces. Lastly, orange, 25 small, 40 large, 25 times 8, 40 large. So 40 times 14, 760 ounces. Awesome. Well, that leads right into question C. How much more apple juice is sold than grape juice? Subtraction? Of what?
Pretty great.
Apple minus grape, right? Find how much apple juice was made, 580, minus how much grape was sold, 290. How many more ounces is it?
290.
So 290 more ounces of apple juice were sold than grape juice. That one's pretty easy, right? Looking at that graph, should be a fairly easy test, guys. Okay?
That's going to be on the test.
What?
That's going to be on the test.
Some of this stuff, like, we do notes for a reason. Like,
But this seems too easy.
alright,
Take this right now.
I'll make sure to make it harder, don't worry. Alright, so for the next problem, we're going to talk about percent increase and decrease. Our formula for that is new minus old over old. I'm not sure if that's something we need to know for the test. I have to look. But that is our formula for percent increase and decrease. It would be the new number minus the old number divided by the old number. So, from January to May, what was Jack's percent increase of savings? Hey, guys, stop talking. So, from January to May, I want to know his percent increase. So his new minus his old. So May would be new, it's 2,000. Minus his old, January, 1,000. Divided by the old. What do you get for that?
100.
You get 1, which would be, what is a percentage? 100%. So Jack has a 100% increase from January to May. Well, how do you think Barbara did?
Please excuse this interruption.
No.
Attention students attending reality check session 6. Please report to the student services lobby at this time and check in with Mrs. Finley. The bus will be leaving at 1:10 promptly. Students attending reality check in session 6, please report immediately to student services lobby and check in with Mrs. Finley. The bus will be leaving at 1:10. Thank you.
Okay, someone walk me through this one. The percent increase for Barbara.
1,500 minus 1,500.
1,500, that's our new. Minus 1,500.
Divide by 1,500.
Divided by 1,500. Both the new and the old are 1,500. So you get 0, which means it's a 0% increase. And the last question. 2 parts to it. During which month did Jack and Barbara have the greatest difference in their savings? And how much was the difference? Well, first of all, let's look. In which month they have the biggest difference?
April.
April, right? That's when they're the farthest spread apart.
Oh,
Jeez. Farthest spread apart. Words are hard sometimes. Alright, so in April, they're the farthest apart. How much is the difference there?
2,000.
How'd you get that, Q?
2,000 minus 100.
3,000 for Jack, 1,000 for Barbara. 3,000 minus 1,000 would be $2,000.
2,000.
Okay? Any questions on that, guys? Pretty easy so far?
Well, I thought it was car code.
Alright. 3 more graphs to look at. So household expenditures. Our first graph is household expenditures in 1950. The second one is in 2010. So, what?
I love how it's colored.
Thank you. So, if we look here, if the household average income in 1950 was $40,000, how much would have been spent on housing? Well, so we're saying that they have $40,000, how much they brought in. Well, what percent of their income in 1950 was spent on housing?
72.
72.1, right? This part is A. So if I know that 72.1% of that 40,000 spent on housing, I should be able to do 0.721 times 40,000. That should give me how much they actually spent on the housing. Did anyone do it? 28,000 what? $840. So in 1950, annually they were spending $28,840 on their housing. If the household average income in 2010 was $100,000, how much was spent on housing? Well, in 2010, what percentage of income was spent on housing? 22%, right? A. So I know that part spent on housing, so 0.22 times 100,000. How much were we spending on housing in 2010? $22,000. Do those make sense, those first two?
Yeah.
Alright, the last one. If the amount of food spent, the amount spent on food in 2010 was $30,600, how much was spent on transportation? How can I figure this one out? What?
The decimal of food multiplied by X equals 30,600.
So the decimal food,
Or the percent food.
okay, so the percent or decimal, whichever. You got the decimal, right?
Yeah.
So food in 2010, food is B. Food was 34%, right? So 0.34 times X, which would be our total amount of money, equal to 30,600. I know I spent that much on food. Well, solve for X, figure out how much money you made. Divide by 0.34. X equals what?
90,000.
$90,000. $90,000. So I know I made $90,000 in 2010. So if I want to figure out how much I spent on transportation, I need to take 90,000 and multiply it by what? Well, I spent E 14% or 0.14 of my money on that. So 0.14 times 90,000 should equal how much money did we spend on transportation?
12,600.
$12,600. Right? So the first step might be just finding how much did you make that year and then multiply that by the percentage for transportation. Now yesterday Noelle had a really great idea. She did it a different way than what we just did. It'll give you the same exact answer, works just fine, but it's a little different than the way we did it. I think it's actually a little bit quicker, to be honest. Does anyone remember how she did it? For those that were here? Cross multiply, but what do you do before you cross multiply? You set it up as what? As a proportion, right? She set it up as a proportion. She knew she spent $30,600 on food, which is worth 34%. She put it over 0.34. Equal to, she wants to know how much she spends on transportation. So X over, and she knew 14% was spent on transportation. So instead of maybe setting it up as an equation, solving for how much we made, then multiplying by 0.14, so how much you spent on transportation, Patrick, keep your hands to yourself. Set up a proportion, and just cross multiply. Gets you the same exact answer. Now, do you have to do it that way? No, you can do it the first way. Either way should get you the right answer. Alright, does that make sense? Any questions? Some of us have really blank stares. That's because they're bored or we don't know what's going on. What? Bored. Alright, we got two more. So first, hey, what type of graph or plot is this?
Stem and leaf.
It's a stem and leaf plot. It's a little bit different than the normal stem and leaf plots. I just told him to keep his hands to himself. Why can't you? Stop. Leave him alone. Alright, so this stem and leaf plot has leaves going in both directions. Perfectly fine. We can read it the same exact way. These are all our stems. So 1, 5 would still be 1/5, would be 15. 1, 2 would be 12. 1, 0 would be 10. Our first question is asking us, what is the median age of the males? Well, how do we do that? How do we find the median? You what? You could type it in your calculator, but I want to do it on the board. How do you normally do the median? Mason?
Write them out, or least the greatest, and cross.
Least to greatest, and then you can cross them off. Well, good news is these are already least to greatest. They're just a little bit backwards. So I'm going to just cross them out. 2, 0. 2, 1, 2. 1, 2. So I get 51 and 51 in the middle. So to find my median, 51 plus 51 divided by 2, I should get 51 as my median age, right? If I get 2 in the middle, if I'm stuck with 2 in the middle, add them together, divide by 2. I'm going to do the same thing for the females, that's part B. females. My median is between 41 and 42. So 41 plus 42 divided by 2 should give me 41.5. If you do it in your calculator, you should get the same exact thing that we got. Perfectly fine if you want to do it that way. Just make sure you type it in correctly. Please double check you typed them all in your list correctly. Otherwise you can get the answer wrong. Alright. How many more males live in the apartment complex than females? Jalen, how many more males live there than females? How would you do it? How would you go about doing it? Add them all up. What do you mean by that? You don't know? Well, what does each of these numbers represent? They're the ages of the people living in the apartments, right? So if I count up the number of ages of males and the number of ages for females, I should be able to subtract them. Just figure out how many more there are. So each one of these is one person. So 1, 2, 3 people are in their teens. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. There are 26 males in the apartment complex. Which means there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 females that live there. So how many more males are there than females? 12, right? You just subtract them. 26 minus 14 equals 12. Hey guys, sidebar here, quick. If you look on the female side, if we just look at the female side, so we cover this side up. If you were making this stem and leaf plot, would you still put the 3 there?
No.
So if we were making it, and it looks, that's not going to work one bit, is it? So if this is our stem and leaf plot, would we still need to put the 3 there?
No.
Yes, we do. So our stems need to go in order. Even if we don't have a data point for the 3, we can't just skip over it. Alright, so it should be 1, 2, 3, 4, 5, 6, 7, to the minimum to the maximum. And even if we don't have any leaves for the 3, it should still be written there. Alright? Okay, sorry. The age 42 is what percentile for males? How do we find percentile? Does anyone remember?
Yeah.
Grace, how do you find percentile?
You would multiply so you would find 42 and then count all the numbers that are at or below it.
At or below. So we're going to count for males all the numbers at or below 42. Well, 42 is at 42. What about this 5 next to the 2? Do I count that? Why not?
Because it's above.
It's above. It's 45. So I know anything in the 30s. I can count. Anything in the 20s. Anything in the 10s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. Out of how many total numbers did we have? 26. And remember, we're going to multiply that by 100 to get a percentile. Hey, guys, do percentiles ever have decimals? No, right? It's always a whole number. It's 1 through 100. 0 through 100, technically. So what percentile would age 42 be?
42.
The 42nd percentile. Oh, that's weird. 42nd percentile. Hey guys, if you put 42% there, what's going to happen on the test? You going to get it right? If you put a percent sign after 42? No. Right? It's not a percent, it's a percentile. They're different. Lastly, the age 42 is what percentile for females? Well, do the same thing. Find 42. Count everything at or below it. 1, 2, 3, 4, 5, 6, 7, 8 out of 14. And then times 100 gives us what percentile?
57%.
57th percentile? Any questions on that? All right, we have one more graph to look at. 3 questions to answer. Okay? Think we can do it?
Yep.
All right. What kind of plots are these? Box and whisker plots, right? There's 1, 2, 3, 4, 5, 6 of them representing egg lengths. Right? Talking about birds and their egg lengths. So our first question, here I'll leave that up there so we can look at it. Our first question, which bird has the greatest overall egg length? And why? What do you guys think? Mason?
Hedge sparrow because its maximum is the greatest.
Hedge sparrow because its maximum is the greatest. Okay?
What does it mean by overall? Like average?
Like the overall, who has the biggest eggs overall, you think?
Wouldn't it be hedge though? Because like their minimum is the greatest out of all of them too.
Realistically, this is just an opinion question, right? As long as you explain why you think it is, you'd get it right. Now, I don't think we're going to have an opinion question on the test. But, yeah, you could use hedge sparrow because it has the greatest maximum. You could use hedge sparrow because it has the greatest minimum. You could say the hedge sparrow because all of its data is above 21.5% or 21.5 millimeters, and none of the others can say that. Right? So as long as you justify what you think, for a question like that, you get it okay. You get it right. The second one, approximately what percent of the wren's egg length is below all of the rest? Well, if I look here, that's where the rest of them are. So what percent of the wren's egg lengths are below all the rest of the data points? William, what do you think? What percentage of the wren's egg lengths are below everyone else's?
50.
50? Why do you think it's 50? I agree with you, it is 50. 50% of the wren's data is below. But why is that? You can phone a friend if you need.
Colton.
Well, I didn't give you that option.
I don't know the answer.
You don't know? Make sure you pick our heads up so we can pay attention.
I was paying attention, I just don't know it.
Colton, why is 50% of its data below?
Each area represents 25%.
Each spot in between these lines is 25% of our data, right? We talked about that. Between the minimum and Q1 is 25%. Q1 and the median is 25%. Median and Q3 is 25. Q3 and the maximum is 25. So if we're at the median, we want to know all that's over here. I know that's 2 quartiles. I know that's 50% of my data. So 50% of the wren's egg lengths are below everyone else's. And lastly, C. Compare the plaid wagtail and the meadow pipit. Which has a greater overall egg length and why? So we're looking at these two. Right here.
Flood's really cool. Isn't it an opinion question here?
I mean, it is, but there's really a correct answer to it.
Yeah, flood's right
Paige, what do you think? Why do you think that? It's longer. Like, do you have like any other data to use to maybe justify the answer? The maximum number's higher. All right, that works for me. Anyone else have a reason why they might think that number 4's got the greater overall? Colton?
Well, the 50% is higher.
The 50% of its data is higher. Well, how about that 25% of its data is higher than anything else in the number 5? Right? So you guys use something on there to justify your answer. Don't just say it's longer. It doesn't tell me anything. Say it has a higher maximum. Say it has 25% of the data above the rest of the meadow pipit. Say it's 50% of its data is higher than 50% for the other one. Use the data that's given to you on the graph, on the plot. Alright, justify your answers. And make them good justifications. Alright? Does that make sense? Any questions? Alright.